Good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key of enhancing our performances and for our growth as professionals. With this principle in mind, TechGig has initiated a series of webinars conducted by industry experts to give a crisp insight of various domains. Today's session is on Big Data Analytics, What's in it for you at IMTC, which is going to be held from May 9 and 11 at Bangalore. Our guest speaker today is Mr. Srinivas Kulkarni, Senior Architect at IBM. Srinivas is a Senior Architect leading the IBM Big Data Platform and Solutions at IBM India Software Labs. He has been working with IBM for over 12 years with various roles and experiences in product architecture and development, solutioning, enterprise integration, customer enablement, and technical evangelism. Gentlemen, this presentation will continue for next 45 minutes and your questions will be answered after the presentation. In the meanwhile, you can post your queries through the chat pane available in the webinar software. Without further ado, I introduce you to our guest speaker, Mr. Srinivas.
Hi, can you hear me now? Operator,
Yeah.
can you confirm that?
Please go ahead.
Okay, thank you. Hello, everybody, and thank you for attending this session. Today, I'll be taking you through what's been happening in the big data analytics space in general, and what is leading to the kind of the analytics that we are talking. And then, as you earlier mentioned, we have an event called IMTC, Information Management Technical Conference, that's happening in Bangalore between May 9th and 11th, where we'll be talking about a lot of information management related technical concepts. It's a place where all technical folks from different companies, customers, everybody comes and meets. And so we have a separate track for big data, various talks, very in-depth analysis, and technical sessions in that. So what I'll be talking here is an overview of what all we'll be covering there in depth. Okay. So in case you have any questions, please post them in the chat. So if it's in the context, I will take those questions, and if not, we'll take them towards the end of the session. Okay. So let's get started. Now, I just want you to look at some of the things that you see on this. Right? Just consider this for a moment. You see, Google indexes billions, trillions of records, documents, and when I and you search, we get results in this split second. Look at Facebook, over 900 plus million users. Generate almost 10 terabytes of data every day, right? Which is equivalent to almost 5 billion pages of text. And still, when I log in, every time I get surprised when I see that, some suggestions saying this person may be your friend. Think of it, how can someone where 800 million people are talking, doing a lot of posting, chatting, and all those things, it still figures out different relationships, going by all possible relationships, and comes up with an answer. Think of any of these internet scale companies, be it Yahoo, LinkedIn, Twitter, or Foursquare, any of these things where they're crunching huge amount of data and giving us sensible results. That's why we're going to them. At this point, I wanted you to think for a moment as what kind of technology would be behind these things to crunch this massive amount of data. Right? And at the same time, think in the situation that where you are or your customers are, what kind of problems are similar in nature. Of course, I'll be talking about some of those things as we proceed, just to give you insights around that. Now, I just want to begin, set some more context. Begin with two extreme cases, which we call the extreme ends of big data. On one hand, this is one question that IBM researchers took a few years back, said, can we design a machine, a computing system, that can actually rival humans' ability to understand the context when a question is asked and answer? It's not just like a search kind of a thing, but understanding natural language and answering. Right? So, in order to decide what's the best thing, in early 2000, when we wanted to build the best machine, we made a game, chess game, the Deep Blue machine, and made it play against the champion, and we won. Right? This time they took an interesting question, a game called Jeopardy, where in the game Jeopardy, the questions will come in the form of answers, and there will be categories. There will be 3 contestants, and there will be questions. You choose a category, and there will be question around you. So the category could be politicians of India, right? And then the question might come was this politician was 13th Prime Minister, right? So whoever is the 13th Prime Minister, I don't know exactly who it is, but the machine, it's much easier because it can be fed with all the information. It can just go search and give answers. Now think of a category like 70s, right? The machine doesn't have any idea whether 70 is a number, whether 70 is the age of a person, or is the 1970s or some other 70s. We have no idea, right? And then the next thing, the question will come in is, this septuagenarian scientist was a head of a large democratic country, is also interested in children and education. Now think of all these dimensions that are being given to you. It said that the scientist is a head of some country, democratic, large, children, education. As humans, we look at it and we say, the answer is Dr. Abdul Kalam. How do I make a machine understand that? Here, not only it has to understand the natural language, not only parse it into the right things and understand it, but it also has to understand the context in which the question has been asked. Like it's very sophisticated text analytical and deep question answers thing, right? So basically what we did was we built a machine called IBM, and in June we played against 2 of the champions in Jeopardy game, and the machine won. Right? So showing this tremendous advancement that happened in the deep QA analytics world. The other extreme I would like to take is this was what is called known as IBM Data Baby. Now there was a hospital in Canada where they wanted to try this thing. They have these neonatal care hospital, right, where they have these babies which are prematurely born, which are kept in I don't know exactly what the word I'm not getting. The boxes, right, which are connected to various devices, like you have ECG, EKG, heartbeat checking, and temperature, humidity, and all those things. Now, this researchers realized that if I look at them individually, even if I'm monitoring, I'm not actually going to make much progress. It's a very, very delicate thing, right? It's already prematurely born, and any small changes in the pathway can make a big difference. So, but what they realized was, if I can look at all these devices in the context of each other and look at the different signals that they're sending, one could be sending some sinusoidal waveform, something else is sending some other kind of signal, something temperatures that maybe simple digital. So if I can correlate, do a massive correlation across all these things, they figured out that actually the onset of an infection could be figured out a day in advance, 24 hours before the actual infection happens. That is a question of life and death for a prematurely born baby, right? So one thing, this example is, this is the other extreme where you have, and this is for one baby. Now think of a hospital will have hundreds of such, right, if not thousands, in each hospital. And if you have a network of hospitals, a lot of them, and each machine is pumping a large amount of data, and I need to do this massive correlation and take a real-time decision. So with that context set, which is the two extremes of it, I'd like to get into some of the realities that we are seeing in today's world. On one hand, the data volume is growing in an astronomical rates. You have almost for 6 billion people on 5 billion people using mobile phones. You have smart metering systems generating a lot of things. RFID sensors are generating data. Just like things like Twitter or Facebook generates tens of terabytes of data every day. And of course the weather systems and a lot of meteorological things, they are generating huge amount of data. Right. Now what we're seeing the businesses are looking for is, there is a lot of value in understanding what is being spoken in all these places. So for example, what is a company? If I am someone like I think this Unilever, I would be interested to know what people are talking about my products on Facebook. Are they happy with the latest shampoo that I released? Are there any issues they are having with and they're discussing on Twitter, or are they sending me some emails that I'm not able to listen to? So they know that there is a lot of value out there, and they have to tap into it. Otherwise, sometimes you have your brand erosion without you knowing. Right? But the thing is, they don't know where to begin. How do I do it? Right? They want to predict what is the risk here. Based on real-time transactional data. And the interesting part here is, on the left side you see, of this data, 80% of it is unstructured. We've been used to dealing with a lot of structured data in the last 30 to 40 years. We have built amazing systems, no doubt about it. Very highly optimized, highly sophisticated systems, but most of it is around structured data. But here we're talking about a lot of unstructured content, which it could be in terms of text, it could be images, videos, even generated from sensors, weather data, and so on and so forth. So now let's look at, when we say that businesses want to make use of this data, we a year or two back we went and asked some of the customers, some of them were very well advanced in analytics. We asked, okay, we understand that you have these various sources that you want to tap into. What are your top issues around that? How have you been doing? So you can see some of the things here, right? The summary was, they said, we understand there's a lot of potentially useful information there. Now, either we are discarding it because we cannot store it, storage is too expensive for us, or because even if I store it, due to performance reasons, I can't make any sense out of it. It's too large, and it's not at all structured to put it in my databases, in my warehouses, which is what I'm used to. And one of the very important thing that came out of this was, which is what I've bolded in point number 3, is they said, unlike the old world, we don't know where to begin. Right? It's not that I know these are the columns that you need to look for, create a chart for me. It's not as simple as that. It's quite exploratory in nature. There's a lot of data. I need to go through that data and find something, and then get to the next iteration, use that information, and start finding more and more. There's no one clear point where I say, here is where I'm starting. This is one big. This actually sets the whole notion for how big data analytics is all about, how it differentiates from the traditional analytics. We'll see in the next slide. So one thing was very key. They said all this analysis that we are seeing, right, we cannot do it in isolation. It has to be done in the context of the rest of the information that I already have that I'm using. It may be my warehouses, or it could be some other application that I've built in. I want to use all this unstructured stuff, the new world stuff, in the context of my existing information and make sense. Right. So yeah, so this is, I'll give a pause. Okay, I hope it's a refresh view. I would see there's a shift in the way we are approaching analytics when it comes to big data. In the traditional approach, it is very simple. business knew exactly what they wanted, and they asked their IT, this is the kind of the report I want. Go build the report. It could be as simple as I want to know what's the monthly sales reports, how is my profitability, how the sales is happening in this particular region and zone, and so on and so forth. Very simple. Though, I'm saying it's simple, but I understand it's not. When it comes to implementation, we put in a lot of effort there. The thing is, it has been around the structured data, and there has been a repeatability around it. Whereas when it comes to big data, we already talked, it is iterative and exploratory. So the business cannot tell me exactly what they're looking for, what they want, right? All they can say is, I am interested in information that is there in Twitter, information that is there in my emails, in my customer representatives' chats, or their interactions, and some information is there in Facebook. Now you go and give me a platform where I, as a business user, can go and explore it with my domain knowledge, and then figure out what it is used. And then I further prod it and iterate and explore. It's more of discover the data, explore the data, and then make sense of it. It's the nuggets is lying deep down, and it is back. So that's the shift we have seen. So I actually take whenever I speak about big data analytics. So so far I've gone around and spoken to close to 1,000 people in India, customers, business partners, and all. I take generally this example, right, which is comparing how the shift has been in the analytics world. You have whenever in the late 18th century, early 19th century, anybody who wanted to get some gold went with just a shovel and some simple tools and did some very simple process. Came back with some amount of gold, at least in California. Right? And today we have extremely sophisticated machinery. Just to get the 1 ounce, 1 gram of gold, we put in a lot of time and money and all that. By the way, these pictures are, especially the machinery is not gold industry machinery. I had to get some copyright-free things, so I ended up having the best effort. So going back to the analogy, right? Why do I take this analogy? Here, if you look at it, what happened between the 18th century, 19th century to 21st century is the density of the gold in the soil went down drastically. There was extremely high density, so simple tools could get you what you wanted. The same is happening in the data world. Earlier, we have very high density of information compared to what we have today. Let me give an example. Right. In the traditional world, what we did was we captured only that data that was relevant to us. Right. In fact, we started from the outside-in approach. We said, for this application, I want these kind of reports. I want this kind of output. Now, let me go back and map it to what kind of input that I need to store so that I can get this output. Right. So, in other words, every bit or every byte of information that you store in your databases or warehouses had a direct relevance, direct mapping to the reports or the outputs that you were looking for. So it was almost like 100% density. Whereas today, if you look at it, right, I want to understand what people are talking in Facebook about my product. It generates 10 terabytes of data every day. I need to search through it, analyze all the data, maybe to just get 10 insights. That like 4 people are happy about it, 2 are unhappy, and other folks are neutral. Now think of it. Your insight is these 10 comments, and you search through the whole world of data. Right? That's the, if you look at this ratio, that's information density that we're having today. Right? So now, clearly, we need an equivalent of today's gold industry kind of thing. Right? Very sophisticated machinery, sophisticated tools and techniques. Now, what we're seeing here is our vision of what a typical big data platform should look like. Where, if I want to do any analytics using all this data that we are talking about, we need some pieces. So if you can think about it, each of them are like themes. They are not like products or anything. They're themes where you will see a lot of people working on and investing. One thing very clearly, this is going to be huge amount of data, right? Extreme amount of data. It is hitting at a very, very high speed. And we've seen cases where we have 5 million events hitting every second in the financial world, right? Yet they are looking for responses in microseconds correlating across all those events. And then because it's so high rate, the volume is going up, and then the variety of information sources is again unimaginable. You have on one side, you have things sensor generating RFID data, the telemetry data, or the text coming from social media or corporate world, whatever. So we need an infrastructure which can scale out, massively. That's why I gave the examples of the Googles and the Facebooks, who are crunching really serious number of data, right? I get a question that the voice is breaking. Is it really the case? Do I need to switch to a phone line, or can I continue? Operator, can you please confirm? Hello, operator. Okay. I think I'll just go ahead, and if there's any more voice breaking, please let organizers know. I'll get to know. Okay, so there is a question I'm getting here, which is asking, are all these areas connected? The listed area like data warehousing, data mining, business intelligence, data analytics. Yes, they are very much connected. If you can just hold on for a few minutes, I think some of the things will be quite clear. If not, we can take this up again later. But they are very much related to each other. Okay. So one thing is you need to have this platform infrastructure layer which can work. I can start with generating 10 MBs of data, and I don't want to change the code when I move to 100 MBs to 10 terabytes to a few petabytes. Right? I want to keep the same code without doing anything else. So that's a massive scale out. So we need that massive scale out architecture-based solutions. And the second thing is, for every small thing, we don't expect you to sit and code every line of things. Say, for example, I want to understand the sentiment of people in the social media. Where do I start? Do I start with take the thing and tokenize it, build regular expressions, and then start building up everything, and then say, okay, this is a noun, this is a verb. Now identify that and how they are linked together. Based on that, I'll come up with something. That's too much things to expect. And, that's what we used to do a few years back. But if you want to do serious work, that's not going to work. So you need higher level of abstractions when it comes to analytics pieces. So we call them purpose-built piece of analytics, and they cater to different varieties of data. Similarly, if I want to do the image analytics, for example, if I want to search, you've given a set of images, I want to say, show me the images which are related to wedding or related to a child or whatever, right? So that's image analytics. Similarly, on the video analytics front, I want to understand, some surveillance camera is put in an airport, and I want to be notified only when someone has left a suitcase and it has passed 10 minutes and that person hasn't returned back. It's a minute or two, I don't know. So I want that level of abstraction programmer to code, not to get into the frame-wise. And then similarly, you can see various things. I want all machine learning things, or I want to do data mining. So this was related to the question we already previously got, right? So I want to do data mining using all the data that we have. I want to mine for certain patterns. Can I get the existing algorithms rebuilt, or I want to do some predictive analysis? Again, could be based on machine learning, could be based on some other rule-based things. So you need any platform has to have these capabilities. And then now if you want to build solutions, you need good IDEs to build solutions, and some big data brings its own challenges when it comes to visualization. So you definitely need to figure out what kind of visualization techniques make sense. Is it some spiral chart, or is it a cloud, tag cloud, or some other way? Right? And of course, all these have to have enterprise class capabilities like reliability, fault tolerance, and all those things. And the most important thing, which was one of the key things that came out from our question to the customers, was I cannot do analysis of this data in isolation. Right? I'm doing a lot of analysis already. I'm doing a lot of business intelligence with, and I have my existing products which are doing it, my solutions, and whatever we are doing in this new big data analytics has to be integrated tightly and seamlessly with the rest of the information architecture. Right? Meaning, I want to, in other words, I want to marry these structured and unstructured world to actually get more insights. For, just to give an example, right? I may be seeing that people are talking on Twitter that in Bangalore region, certain of my product is really doing good. We are very happy about it. Now I want to make sure that I want to correlate it with the sales data for Bangalore region, and then see whether the sentiment of people is getting positive in the month of April, the sales going up. If it is, then it makes sense. Otherwise, there's some problem, right? Okay, so we'll move to the next slide. Meanwhile, I'm seeing 2 questions. Give me a second. I'll just look through it. So one of the questions is, what are the open source integrations using big data? I think what you're referring to here is what are the open source products that are there, and how do they integrate? If so, we will cover that. And are these, how to start on the data? That's a good question. It's with respect to learning algorithms and data structures and so on. Yeah, so I'll just take the starting point one. So already what you're doing is like the initiator, right? You already have invested your 1 hour 15 minutes today. That's a startup. Then after, I would suggest after this, you can go to YouTube. There are a lot of YouTube videos which talk about various things. So maybe it will be good if I take more details of the answers on that after this particular slide. It will be in context. So what you're seeing is a slide called Big Data Dimensions. So we talked about these 2 use cases early on, right? One is the IBM Watson, and the other one was the IBM Data Baby. Now, if you look at it, the Data Baby was all about real-time analytics. I want to analyze what is happening in real time. For example, in financial markets, we worked with a bank where they wanted to do algorithmic trading on options, and they were having almost 500 million different data points coming into the system every second, and they wanted responses in microseconds. Right? So that's a real-time side of it. And the other side is, as we start storing all this real-time data, the information starts growing, and if I want to say mine for certain patterns, what's happening here, what are the top 10 requests from people about, say I have an iPhone, and I want to understand, say if I have an Apple, right? I want to understand what are people looking for, and everybody is talking on various forums, right? So I want to analyze all the content in all the forums. That gets into this is more batch mode. I'm not interested to get the result in a second or 2. can wait for a few minutes or maybe hours, depending on the size of the data that I'm crunching. Right? Now this can get into terabytes to petabytes to exabytes of data. So we clearly understand that the two are different types of workloads. There is no one technique that works for both. We have these, traditionally, if you look at warehouses and business intelligence, it fits in, I have data up to a few terabytes, say 60, 70, up to 100 terabytes of data, my warehouse is size. And then I can get the responses in milliseconds, I'm happy. Right? That's the middle tier, which is the traditional data warehouses. Now we are talking about the other extremes, where I have too much of data, like petabytes of data, and I can wait for minutes to a few minutes. Now the thing is, because there is so much of data, you have some issues around it. How do we deal with it? So we have two different products. Now I talk sometimes about some of the IBM products, and other times I try to be as agnostic as possible. So on the data in motion, or analytics in flight, we have a product called InfoSphere Streams, which is meant for an analysis of real-time data at extremely high rates. And another thing called InfoSphere Big Insights, which is based on an open source Hadoop framework. We will see what Hadoop is very briefly in the next slides. And then there are additional IBM enterprise capabilities that we have added on top of the open source Hadoop. So this is the answer to the previous question that we had, is what are the open source things. So Hadoop is open source, and there's a whole lot of ecosystem around Hadoop. That is an open source component. We take it like how you see Linux, different distributions of Linux, and same core Linux they take. Similarly, Hadoop is open source. We take it and then we harden it, and we add additional capability on top of it, which we think are useful to our customers. So these are the two dimensions of the big data we are seeing. So most of the time when you see people refer to big data, you will see only the data at rest. So it will not be a complete story if you only look at one dimension. Okay. So I'm got one more question here which says, can we relate big data with the UIDAI project of India? The answer is yes, definitely. Some of the cases I can think of they may be doing is, we have billion people having so many records. Could be simple thing like they're collecting, I think, all the 10 fingers, the fingertip biometric information. So doing analysis of all that, right? And doing analysis of, if I go and subscribe to them, they need to try to see if I already subscribed earlier. So I need to be deduplicated against the rest of 1.19 billion people, right? So definitely that's a scope for Hadoop. And I do know that UIDAI uses Hadoop, but I can't get into the details of that at this point. What kind of algorithms are employed in analysis of big data? It depends on the kind of workload you're looking at. Say, for example, there are various machine learning algorithms. So if you're interested in identifying certain patterns, you want to do regression analysis, then you want to do machine learning based algorithms. Or it could be simple other analysis that you want. You can write your own analysis programs, and there are different languages, higher level languages provided that come with Hadoop and as well as streams. So you can create your own algorithms. There are no very specific algorithm for big data itself. No, okay. So having said that, I will talk about the technology that's available. What we are saying, Hadoop and streams, they themselves have certain algorithms built in which help you as a developer which kind of unburden you from figuring out all the details. Right? So that is to answer what are the new algorithms that are there on this. Right? So in the interest of time, I'll just move over. This is how a typical platform looks like in the screen. What you're seeing. you will have the big data enterprise engines, be it the warehouses or the Hadoop or streaming engine, which imposes the streams, and then you have various connectors to connect to your information systems, and then you build applications, assets, and so on, and then a whole lot of connectors to connect to integration. Now I'll talk about each dimension, a few slides on each dimension. Now, as I said, this is a very wide subject, and it's in 1 hour covering this is actually a big challenge for me. So what I'm doing is I'm doing not a 50,000 feet, but maybe a 20,000 feet stuff is what I'm giving you. But what we'll be covering in IMTC, the IMTC conference, is each of these subsections will be covered as full-fledged sessions there. So you have 5 or 6 sessions, I think, on big data, in depth, getting into very details of customer cases and our experience sharing and all that. So I urge you to consider coming to the conference. Right? But here, however, we will go, and if you have any questions, you can reach out to me, and we can do detailed ones later. Now, so I've been talking about this thing called Hadoop. I don't know how many of you are aware of Hadoop, but in the interest of everybody, I'll just introduce Hadoop at a very high level. So Hadoop is where you have issues of want to crunch a petabytes of data. For example, Facebook has total 30 petabytes from the public information that they've provided. I understand that there are 30 petabytes of data, and now they have to analyze all that. Right? So before we get to the technical thing, I want to take a very simple example, which I've seen in the Indian context works. Say, for example, a simple coin counting problem. Right? If I give you a bag full of coins and say you find out how many 1 rupee coins are there, how many 5 rupees, how many 10 rupee coins are there, how many 2 rupee coins are there. Just do it to me. Fine. What do? You just have maybe some counters for each one of them, and then you keep increasing, plus one, plus one, plus one, as in when you see each type of coin, and then you say there are 21 rupees, 42 rupees, and so on. You come back. Now, this is simple, right? Not much difficulty. If I give you, say, 4 bags, you'll still somehow manage. You'll do maybe one at a time. So you're doing it serially. Or you can say you'll employ 4 people, and then all of you are doing something. Now think of something like Tirupati. Right? For those people who know about it, so many devotees keep going there, and then you keep putting different coins in the hundi, and then if you see all around the temple, there'll be people sitting and counting. Right? That's actually a big data problem, the coin counting. So what do? Suppose they store all these coins in one room, and they understand that one person cannot count, so they deployed, say, 100 people to count. Where do you think is the bottleneck? Right? People are fast; they can count very fast. But the thing is, all the coins are in one room, and everybody has to go through one door and get it. Right? So you'll see bottleneck in 2 places. One, everybody has to go through the same door. Right? So there will be a congestion at the door for others to go and I can get in. And then there is this me going around every time I have to go there, get the coin, and come back and sit, count, and go back. The counting, the counting is very fast, but the problem is in these things. Now, come back to our problem, right? The data side. It's no different. Right? So think of it. A person as a CPU, right, and this large room as a large file system, or something like a large storage. If I want to distribute the work among, say, 100 different CPUs are extremely fast, but the problem will be the I/O. Right? Even at the we have, even if you say around 100 Mbps. 100 MBs per second is a fairly standard thing in the I/O, and if I want to read 1 terabyte, just reading, okay, I'm talking about just reading 1 terabyte off the disk, it's going to take me 3.5 hours if it is one single disk. Okay, so that's a big bottleneck where my analysis can be done very fast by all these. I can scale out these things, but I.O. is still my bottleneck. Right. So what is the solution? What if I make it into 10 disks? Well, calculation shows it's 20 minutes. What if I make 1,000 disks? It's 12 seconds. The same amount of data I can read in 12 seconds, right? So how now the question comes is how do I how do I make it happen? So we go with distributed file systems, and this distributed file system. So one thing is we did the compute as parallel, right? Parallel computing, and then the next thing what we need to do is, in order to make these 1,000 disks read, why not I make use of the disks each of the CPUs have as part of the storage, and I build a logical structure around all these different disks and make it into a distributed file system, right? So not only I made computing parallel, I made the data local to that compute node now. So each of them are reading in parallel. They are doing their bit of analysis, their bit of work, and then the work is getting merged. Right? Now, in order to do this, we need a separate programming paradigm, the good old way of working the work. Because here we are saying we are splitting into any work is being split into two phases. One is called a map phase, and the other one is called a reduce phase. Right? So this is a programming paradigm that Google came up in the early 2003 or 4 time frame when they wanted to do this search on the massive scale of things, and they wanted to deploy the commodity machines. And they knew that because they're using the commodity machines, the machines are going to fail. Even our server class machines, they are going to fail. So they build the reliability in the software itself, right? So in the MapReduce paradigm, what it says is the map phase will split the input into different pieces, and each map will work on one split. And the orchestrating engine has to make sure that the split is local. So basically, if a file is split into, let's say 10, a file of 100 MB is split into 100 blocks of 1 MB each, and now I'm storing each block in one machine. And now I'm saying, machine 1, you read the block that you have, you read the split that you have, do some analysis. For example, it could be, say, word count, right? So I'm telling you do the count of the words for the part of the document that you have, and machine 2, you do the stuff that you have, and then you all give it back to me. That comes to the reduce phase. In the reduce phase, what I'll do is it's actually like a merge kind of thing. I look at it and I'll say, how many, say, so going back to our coin counting, I say how many coins machine 1 comes back. It says 1 rupee, 3 rupees. The second machine comes as 2 3 rupees and 4 rupees. So I'll just do the merge of these two and say this is my result. Right? This is in a nutshell what MapReduce programming paradigm is for you. Now you are reducing network bandwidth big time, and you are parallelizing I/O, right? And you are making use of your CPU. Okay. So there is one question I'm getting, a very interesting question, which is how is the sarcasm dealt with while doing the sentiment analysis? Very good question, very relevant question. We'll see it when I talk about text analytics. Okay. And there is another question, which is any difference between data analytics and big data analytics. So the difference is this, that when the data gets to the scale of multiple hundreds of, and by the way, there's no one fixed answer which is how big is it big. It depends. If my existing framework, my existing techniques don't work, that's when I'm into big data issue, big data problem. So all the same analysis that I was doing in a small scale, I want the similar results maybe on the large scale, and some more exploratory stuff. So that makes the difference between traditional data analytics and big data analytics. Okay, so we talked about Hadoop, we talked about MapReduce. So Hadoop is nothing but another MapReduce. So MapReduce was a paper that Google published, and then they had their own C++ based implementation. And around 2005 time frame, Doug Cutting, who was the creator of Lucene, which is the de facto indexing standard, and Nudge, which is a search framework open source search framework. Now they hit upon this issue, and they used this Google's paper and created a Java-based software, and they made it into Apache, right? Apache licensing. Because Apache licensing is very friendly to commercial software, a lot of commercial software companies picked it, and he named it Hadoop, right, based on his toy elephant of his son. So Hadoop is nothing but an implementation of Google MapReduce, original MapReduce paper, and in addition, he also created something called Hadoop Distributed File System, also known as HDFS. That is to give an abstraction of a file system over all these machines that are distributed. Right. So again, I'm not getting in depth in Hadoop because it's in itself, it can get in days. Right. So, but there are very huge amount of material available on the internet, especially very good stuff on YouTube. I would say you can go through it and you will learn a lot. And then there are very good books on Hadoop also. Now, of course, there are certain limitations that Hadoop has. Open source thing. One, there's open source. There is no support. Just like any open source thing is. And then it has certain high-level languages. Now, I talked about this programming paradigm. So it is very cumbersome for anybody to think all the time in terms of map and reduce and how do I do this, what code to put in map and what code to put in reduce. So there are higher level languages called Pig in Hive, and IBM also has something called Jackal. Again, it is an open source thing. So Hive and Pig have certain limitations. That's what Jackal bridges. And distributed file system called HDFS had an issue, still has an issue. It has a single point of failure, so we need basically something to alleviate that. So as I was talking about the enterprise class capabilities that IBM has, it has addresses some of these issues and to make it more robust. Right. So I'll quickly give you. So far, what I was speaking was more of a generic, product agnostic things. I'll be talking few minutes on the two products, IBM Big Insights and InfoSpace Streams. Okay. So as I said, Big Insights embeds open source Hadoop, and I hope by this time it is very clear that Hadoop works on a cluster of machines, and you can scale up any number, theoretically any number, but we've seen practically around 5,000 individual compute nodes making one cluster. Big Insights actually packages open source Hadoop and adds, in addition to things like how do I make it easy deployment. Suppose I say these are my 100 machines. All you have to know is the IP, or you can say all their IP are something like XYZ dot 92.62 69. That's my range of IPs. That's all you need to tell, and the installer will go push all the installable each of the nodes, install it, configure it, and do it. Right. This is an additional value that we are providing. And then there are various connectivity to different information things, sources like databases, warehouses, optimized systems like Netezza, ISAS, and so on. Nice IDE so that you can actually get a Big Insights perspective or a Streams perspective instead of doing all in the Java perspective. And then some other things that I'll just cover in the later slides. Okay, there is one question I'm saying: at what point of time do we decide to move from traditional RDBMS to big data system? Okay, good question again. If you can just hold on, once we talk about this, I'll get back to that question. Okay. Now, if you look at these are the components that you're seeing here. All the components in yellow. I hope you see that as yellow itself on your screen. They are all open source components. Okay. So you see, Hadoop, and you see HDFS and HBase, and these are different pieces in Hadoop ecosystem. And in addition, all these blue ones, what you're seeing is IBM addition to them. For example, Big Index, which is for large-scale indexing on a MapReduce method. How do I do it in extremely high rate? Or text analytics. I talked about higher level of abstraction of the text analytics. So now the thing is, each one of them, if I start detailing, it will take time. So what I'll do is, today I will just detail something on the text analytics and give a summary of the rest of the differentiators, right? And either if the questions are there specific, we can take them, or okay, I'll tell in IMTC we'll be dealing with each of those components in depth. Right? So let's take this text analytics. So sentiment analysis, for example. So there was a question which said, how do you deal with sarcasm when it comes to sentiment analysis? Very valid. For example, it's simple. Now, one thing is we have a language created for dealing with text analytics, where we have built applications for sentiment analysis, figuring out what consumer behavior is, what is of interest, what is intent, right? And there are certain libraries, there are a set of annotators that come with the product. For example, understanding, given a financial statement, understanding what is an acquisition, concept like acquisition, it understands that. Things like earnings, it understands no matter how it is written, it figures out those things by default. So these, some of them come out of the box, and then there is a tooling and a separate language is provided. You can develop your own things. Right? So, for example, just take some of the Twitter messages or tweets that are here, right? For example, in the first one, someone is saying, I had an iPhone and it's dead, and I want to buy a BlackBerry. So someone who is running, someone is research in motion who has BlackBerry, right? They want to see this. There's the intent of buying in just saying this, right? And someone is saying, I want to move to a different place. I want to move to Bombay, maybe in 6 months. So someone who is like a logistic service provider, he's looking, there is already, some opportunity to make some money, right? Here. Similarly, there are life events people are talking about. So they could be talking. So in this case, we look at, right? They talk about some philosophical stuff like, good, you shouldn't. You don't have any context what they're talking about. And then the person is saying, by the way, happy birthday. That means today, date is likely that this person's birthday. So you're getting more and more information about your customers from the social media. Maybe it's something they're not given, but you are learning from those things. And at the same time, you want to discard some things like spam. So how do I make machine understand that something is spam? And then coming back to the question of sarcasm. Someone saying, as simple as, for example, whenever we say, how is the traffic? Someone says, traffic is terrible today. It's taking 1.5 hours. And I may say, great. But actually, that great is a sarcastic comment. So if I'm looking only at the word great, because there are some sentiment analysis softwares which give certain weightages to the words, and then they just say how many positive words are there, what is the count of the positive words, the total weight of the positive words, minus the total weight of the negative words in that sentence, and that is the weight of the sentence. Now, that cannot get these kind of things because they are not looking at the context. If you want to get the context, then you need to look at previous line. So I said great, but before that, I had asked the question about traffic, and it says traffic is bad. It's taking too much time. And in addition to that, if I'm saying great, that means I'm very disappointed. Not just disappointed, I'm very disappointed. So understanding the context makes sense. So how we can do that is we have this. I said we have this higher level of abstractions for text analytics. For example, when we're starting to do text analytics a few years back, because IBM researchers started doing this, we realized that they had only these CSPL grammar-based or regular expression-based things, which are very, very tedious to work with. So there are two approaches. One is some people use machine learning to do analytics. So you give a set of documents to it, you train the system, and the system starts, when it sees a new document, it figures out all those things and then says, this is a positive sentiment, this is a negative sentiment, and so on. Sometimes it works good, but the problem you get into is if suddenly the system says this particular snippet is negative, but you see that's actually not a negative thing, it's a positive thing, right? So you have no clue why the system is saying it is negative, because there are no clearly, I'm not programmed it, it has learned it, and it is very hard to decipher or to debug why the system said so. So we had a lot of issues around machine learning when we use this for specific sentiment analysis. So that's why we have built this thing called project code named System T based on System R, which became fundamental to relational databases. So they thought, why not apply relational algebra to text? So if you look at this slide, right, you can create, actually in this case, this is an email. We are analyzing an email and we are looking for people's phone numbers. It's not explicitly written, but many times we know that in every email, almost has a signature, and in the signature you are having some emails, or you are saying call me at so, right? So one simple rule could be look for a name of a person, identify a name, and look for some phone number which is having this kind of a regular expression pattern. And if the two tokens are within a span of few tokens, it is between this and that, the 3 tokens or 10 tokens, or maybe between these two there is a limit up to 0 to 30 characters, then that phone number belongs to this person. Right? So if I want to say something like that, here I create a SQL-like view, whereas I create a view for person phone, where I select from person P, phone number N, within a sentence S, and you can see these predicates where it says then person is contained within the same sentence, so is the number, and person follows the phone number within a character. It's as simple as you think you write these things, and each of you write a lot of these rules or these queries, and then you start building views on top of other views, and then that gives you, so for example, positive sentiment, negative sentiment. You can start building views. And you can also look at what is the previous sentence, what is the previous word, what is the context in the previous thing or in the next thing, and based on that, you can actually make some sense. Right? That's why using this text analytics, specifically this big batch text analytics, we have written a lot of interesting social media applications. Okay, and because it uses relational algebra, we can apply all those things that were there in the relational world, right? That has been there in 30 years of optimization, and it's extremely fast when it's runtime, right? So it's Java-based. It's 20 times faster than the fastest external capability that is available today, other than IBM's external analytics. Okay, so another thing is now most of the analysts are used to spreadsheets, like Excel spreadsheets. They deal with this now. But the moment you get into 65,000 plus rows, 64K, Excel breaks down. What if I want to do the same kind of analysis on, say, 30 terabytes of data? Right? Clearly not possible. So what we have built is a spreadsheet-based data analysis and data discovery tool. Remember, customers said we want to discover, we want to explore. This is exactly what they were actually looking for. So it's a web-based tool. All you need to have is a browser, and then on your browser becomes a spreadsheet. And you point to the data, and then you do whatever your manipulation. You apply filters, macros, almost all kind of things that you see in Excel. That kind of stuff is available, and you can plug in different macros. You do the analysis, and then you save it and say now run. When you say run, it actually converts them into a MapReduce program and runs them on Hadoop cluster. And maybe depending on the size of the data, a few minutes or a few hours, you have the results. And you also could have stitched in UI, and then you have the UI appear to you, bar chart, pie chart, graph. And then there are additional performance enhancements, like we created a different scheduling algorithm, and another technique called adaptive MapReduce, payment technology, for making the MapReduce itself faster by the factor of 15 to 20. And then how do I make use of compressed data, because storage is expensive, still I want to store these things. and some large-scale indexing for various applications that we're seeing in the big data world. We're almost at 4 o'clock. I'll try to finish it in another 5 minutes. Now there are various use cases. I won't be getting into the details. I just put it here so that you can see that it's not just specific to one industry, but cuts across all the industries, almost all the industries. Right? Now, looking at the data in motion analysis, right? So, this is again a cluster-based software, but this is not an open source technology. It's a technology built by IBM, proprietary one. The thing is, you say, for example, any analysis, right, that you want to do, you will think in terms of some data flow graph, right? I think it is not refreshing for you. I don't know why. Okay, I'll just move to the next slide. Maybe hopefully it will refresh. Okay, so if you see what is there on the previous screen, where that you will define your data flow in terms of this. For example, this is actually a schematic of an options trader. Okay, in this case, what is happening is there are a lot of information that is coming from, say, pictures coming from satellite, and then information coming from some weather monitoring stations, from agricultural institutes, and then stock exchanges. Based on all these things, for example, it will be saying, I want to understand, I want to filter weather based on geography, and then I want to join that thing with the information that is coming from agricultural institute, and then I want to do a merging and then do further filtering and so on. This is how typically we think algorithmically, right? All you need to do is you need to code it in the same way. Each of these red blobs that you're seeing, they are what we call them operators. Right? That piece can be written in either in Java or C++ and made into an operator and deploy. So all you need to do is do this, and then you say, you test it with very, maybe 10 events per second. It is quite easy to debuggable, and then you say, here is my actual data, and you say, I have this cluster of 20 machines. Here is my data. Go figure out what is the best way of merging all these processes together, stitching these different operators together, such that I get the optimal result. And this is the sweet spot of Webbased streams. It figures out which is the optimal way of doing things, how many operators I need to clone, how many of them I need to club together so that they become part of the same process in the operating system. Otherwise, data flow between processes become an inter-process communication. So it can figure out, and you can also say, these processes never go together or should always go together, and so on. So using this, you don't have to worry about how do I do multi-threading, how do I do programming, or thread-based program. All those, everything is taken care by the system. You just need to worry about the logic that you want to code in. Or you already have a legacy code, you just have to wrap it over and make it available as an operator. Right? And then there are various toolkits available, already built things. The operators, each of the operators I talked about, they are part of the toolkit. For example, I want to do all database-related activities. It's there. I want to run certain mining algorithms or machine learning things. They are available as toolkits. I can just take them and stitch them in a workflow, and you're good to go. Right? And there's a very nice IDE based on Eclipse. You can just use it and runtime debug it and then play around with it. Again, in the streaming, there are various use cases that you see. Starting from figuring out wildfire management, or figuring out based on the smoke pattern, is the wildfire manageable, containable, or it's too much, to in the telco, doing something like ETL. We'll discuss that in one of the use cases. Right. So applications are really endless. Almost, this is part of a smarter planet strategy. One of the key elements of smarter planet is the big data applications. And I've been myself working on smarter planet for the last 4 or 5 years. And this is not something new. We've been working on these things. That in the last year or two, we formalize them and call them part of the big data portfolio. So I'll discuss three use cases. and maybe then after that we'll take some questions. So one use case is this is machine data analytics. Right? So this particular customer had a large network, and they had various log feeding generated from network devices, operating systems, and so on. And they wanted to analyze all these things, and they're generating almost like 1 terabyte of logs every day. They wanted to analyze all those things. And remember, it's about the bringing everything in the context of each other, right? So if I look at, say, my application is failing, and then you have application layer, and your database layer, and your OS layer, and then your physical network layer, and so on. If something happens somewhere, right? If I do look at logs of only that, say, application or application server in isolation, I may not get the right picture. What if I can relate to all the logs across all these layers? Then I'm actually talking some useful sense. Right? So, and then we applied certain machine learning techniques here, and to figure out things like, and then you can start doing some predictive analysis. If you can look at last 6 months of all the logs, and then you see whenever this particular switch goes down, exactly 5 minutes later, if some ABC event happens, then your database connection goes down. If that is the case, whenever I see a switch going down, and then A and B events happening, I know that the database connection goes down. I can take remedial action immediately, right? And then there was another use case I'm talking about is a financial institute. This is a large credit card company, an international company, and they wanted to, what they do is today they model all their customers in segments. So people having this age group, earning so much in this range, living in this kind of city, have this kind of a spending habit, spending pattern. Anything which is beyond that is a possible risk. And now then they apply their risk, their fraud detection algorithm on top of those things. Now, it so happens that even though I and my friend who are living in the same area, having the same kind of salary and everything, have the same spending habit, it is quite possible that in certain month I have a birthday, and in certain month of the year, always I go on vacation. If you look at my personal records for the last few years, you will know that me spending very high in that particular month is really not unusual. But if you put me in part of this bigger group, then you will see it's an issue. So what they did was they built a very, very fine-grained microsegments. They modeled every person's 7 years of credit card transactions, and based on that, they came up with a model. And then now, anytime a swipe happens, you are actually comparing against the model that is built for that particular person, not for a large segment of people. So that is possible because you can build on Hadoop. And the last one I want to take here is a telco case. This is on a real-time thing. So these guys were huge telco operator, and they have this call detail records, and they wanted to. So what they were doing is whenever there is a call happening, it generates a CDR, a call detail record, and which will have something like who called, whom did he call, how much time, which tower, and all that. And that is what is used for billing purposes. Now, they were taking all of that, putting in a warehouse, and then doing the calculation and doing some mediation and so on. Now, because of the switches, the way the switches work, they generate always two CDRs. One duplicate CDR always gets generated in case one gets lost. And it can come anytime in 15 days. So if this company has, say, 6 billion CDRs per day, we are talking about comparing 6 in 15 days, 90 billion records to find if it's a duplicate or if it's the first time that it's coming in. Because if it's duplicate, then I'm billing twice, same customer, right? So it was a big load on the warehouse. So what they did was we used Postgres streams there in real time. Everything is happening in memory. In streams, remember, I forgot to say, nothing gets into the disk before it is analyzed. Analysis happens, in memory still. That's why it's extremely fast. And then maybe you want to land it. So we took all these things, did all in-memory analysis, and did the deduplication. Only the relevant stuff was pushed up to the warehouse, right? And then in other telco cases, we did something like, as soon as someone calls, or you spend $20 worth of phone, I'll give you $4 credit. So I want to do real-time charging. I want to figure out, based on what person is saying, is he going to churn? Is he going to quit my company and go to some other company? So these are some of the use cases that we worked on the stream side. Right. So and just last one thing I'll talk about is what we call adaptive real-time analytics. This is something very interesting. Again, you can search on YouTube for exactly this keyword, adaptive real-time analytics. The first hit will be a YouTube video. Very interesting. It was done for analysts, news analysts. You can look through it. I'll just explain it quickly. So what this technique is, if you do only real-time analytics, or if you do only the batch mode, the Hadoop-based analytics, yeah, you can get a lot of results, but when you actually combine the two, you get actually very interesting results. For example, what I do is I look at, like in this case of a bank, right? It looked at all the 7 years of credit card history. I build a model. Now, in real time, I start watching for certain interesting patterns based on the model. And as soon as things happen, I can, take some actions. And now it so happens that over a period of time, the model becomes obsolete. And this particular streams can identify the model has become obsolete, and you can tell big insights. Go build a new model based on the additional data that you got, and give me the new model that I can start watching. That's how it can adapt itself. The predictive thing can start adapting itself by asking for a new model to be built. So that was the demo that we did with some Twitter analytics. And so I'm not going to go through those all the details at this point in time. So I think already we are way ahead of the time. So I'll just stop at this point, and if there are any questions, I'm open to take questions. Okay, I already see some questions here. Okay, so one question is, what are the technologies available for big data other than Hadoop, or is Cassandra similar to Hadoop? Okay, so as I said, there are two dimensions of big data. So the real-time analytics, it's the streaming. There are other competitors also in the streaming, but when it comes to dealing with extremely large, I haven't seen much of a competition other than EcoSphere streams of IBM. And on the traditional, on the warehouse, on the batch mode of big data processing on the large scale, Hadoop is clearly is the front runner. And then Cassandra is, yes, it's pretty much similar to Hadoop. And then you see all this whole notion around NoSQL and all that. So, so Hadoop is one runtime, and MapReduce is a paradigm. So there are other MapReduce implementations also, and there are multiple Hadoop implementations. So I would see it's kind of getting converged on, because Microsoft had its own thing called Droid, and now I'm seeing they are doing their own Hadoop. So almost everybody is getting on Hadoop. Okay, so the next question I'm seeing here is, how good are the opportunities for experienced candidates as developers to shift to big data analytics? Very interesting questions. Huge opportunities. Very, very huge. The reason is there are very few people in the industry who understand big data analytics and who have skills in big data analytics. So there's a huge demand for skills in this space, and it is not a fad which will go away. It's not, right? It is definitely, because it's not something that suddenly came up and people started looking at it. It's been growing. It has taken its own sweet time to come to this space. So it is going to ask, and there is no option that I can live without big data. So if you're looking for the switch, definitely is the time. You will be one of the front runners. Okay. So next, I'm seeing question. If I want to take the proper coding knowledge of big data, then how is it possible? Okay, I think what you're asking here is how do I basically get started, right? Where do I begin? What kind of how do I build the skills? If that's not what you meant, please retype the question. But if that's a question, I think it will be there in many people's minds. I would say, as I already said, you start with what is available in the internet. Start with YouTube videos, excellent YouTube videos, and there are good tutorials available on Hadoop, as well as many PDFs or many books on Hadoop. And for InfoSphere streams, there is an IBM Red Book, which is freely available. It's a very well written Red Book. I'll tell you, even if you don't do the coding, but just want to understand, read at least up to chapter 3. It's not too much, just 100 pages. So very beautiful thing. And also there is a book called Big Data. I don't know exactly what the title of that. So if you go to IBM.com and search for Big Data, or Google for Big Data within the site called an IBM, you should see one book written which talks about all the big data use cases, why big data, like things that I spoke in depth. The book is written, right? Which is a very interesting book. So that will also give you different pointers to where to go next. Okay. Then next, I'm seeing another question. Says why data updation is not possible in Hadoop. Very good question. Okay. So so this is related to you might have heard that your data cannot be updated in Hadoop system. That's because of a limitation in the Hadoop distributed file system, HDFS. It is historical in reason, because when they built HDFS, they did not think that Hadoop will be used for various use cases that we are using today. So their major thinking was search. That was the domain, search and analytics around that. So what they did was they said, we will, in disk operations, disk seek, right, is basically a time-consuming thing. So if your files are on different blocks physically in different places and different tracks, then the disk has to keep moving, around all the places. So they said, we will have a file system such that the block is contiguously written, and the block is typically 64 to 128 Mbps. Again, you can set it. Its standard is, I think, goes by how much I can read per second. 100 MB per second, then I would go with 128 Mbps. So I can read off the full block in one sequence, right? So now you write these files, and HDFS at that, when they actually architected it, their main concern was the workload is more of read once and write once and read many times kind of thing. So that's why they said we will not make it updatable. It's a read-only file. Write once, read many times. So that's why you would have seen that. But IBM has another file system support called GPFS, Shared Mapping Cluster SNC. So that supports read-write. It supports random reads. It gives you all positive compliance, which GPFS doesn't give you. So all those things are taken care of. And I hope that even in the Hadoop, in the HDFS, and there are more work going on, they will take care of this somewhere in the future. Okay. How do we register in IMTC is one question. So you can actually send me an email, or you can actually look up for IMTC, and there should be a link. Otherwise, you can drop me a note or something, so I can forward you to the right people. But you should be able to search it or how do I register for IMTC. By the way, IMTC is not only big data; it's all the information management product within IBM. So it's industry solutions, analytics, and the databases, warehouses, all those things. Okay, so I'm seeing another question which says, with big data analytics, importance of CRMs will come down, or will it grow as it can marry to CRM? So yeah, I think you have answered it yourself. I don't think because of big data, CRM will come down. They are doing certain work which they are there, and I don't think any company is interested in replacing what has been working for the last 20, 30 years. And this is a question not only about the CRM, but also goes with the warehouses. Right? You're not going to replace warehouses. There are people who talk about Hive, which is touted as one of the warehouse replacement for it's a big data warehouse, and they will replace warehouses. But personally, I don't think that we are there yet, right? Because people will not throw away what they have built in the last many years. So it will coexist, and as you rightly pointed out, you can integrate the two. You can take that data out of that and use it for analysis. And in fact, we have one large bank which wanted to do something like, they wanted to bring all the information sources into Hadoop system and then analyze and discover in the context of other data sources and extract information that is useful and pump it up into the house so they can be used later. A very sophisticated, very advanced use case. So they want to do that. So that's how where it is heading that we've seen. Okay. Another question I'm seeing is, how feasible is it to migrate data from current relational system to Hadoop, and what is the difference between HFS and GFS? Okay. So there are two parts to this question. If you're seeing GFS as the Google file system, I suppose. So, and HFS, you mean HDFS, I suppose, right? So GFS is a Google's distributed file system. It's a Google's implementation, and HDFS is a Hadoop implementation. So it's just that the implementations vary, and because of that, their APIs vary and other things. And I'm not sure if GFS is available for us to use. I'm not 100% sure whether it's open source or free to use. Maybe it is internal to Google. I may be wrong, but that's what I think. But the thing is, I have never seen anyone working on Hadoop but using GFS. That I've never seen in the last 2 years that I've worked on. Okay, there's another part of the question is how easy it is to migrate data from current relational system. This is an excellent question. It's a very relevant question that most of customers have asked when I speak about taking the relational data into Hadoop for analysis. So there are various ways of doing this. One is there are open source things called some softwares. One is called Scoop, which you can use to read or write off your relational sources. Then within IBM we have our ETL tools called information server, like data stage, quality stage. They support reading and writing off between relational and big data sources. And also we have a lot of connectors. Like within big data portfolio, within big insights, we have connectors which can read or write in JDBC, or if it is specifically about DB2, it can read in parallel, so it can do it extremely fast than anybody else. So yeah, there are various options. Okay, so you asked, sorry, you said GPFS, not GPFS. Yeah, so GPFS is an IBM proprietary, it's a commercially available software. So GPFS has been there for the last 10+ years. We just made it some additional things added to it to make it work with Hadoop. So GPFS, as I said, it has addressed certain limitations that were there in HDFS. So HDFS has a single point of failure, something called a name node, where every metadata of all the files that are stored in HDFS is maintained. So if the name node goes down, your entire cluster comes to a standstill. Like you cannot do anything. And maybe taking name node, say like a checkpointing node, some people call it a secondary node, but it's actually a checkpointing node. But bringing it back will take some time. And between checkpointing and when the failure happened, whatever data was there, it is lost. Right? So that is one failure point of view is one of the problems. And another thing is, say you want to have a large number of smaller files. Remember I told in HDFS you have block sizes of 64 MB, 128 MB, and so on. So what if I have a million files of 10 KB? Now one thing is my name node. In my name node, metadata is all, by the way, metadata is all maintained in memory. It's not written to disk unless it's checkpointed. So memory goes up. Memory becomes a limitation there. And so GPFS addresses it in a different manner. In GPFS, there is no single point of failure. So not only data, metadata also gets replicated across. So if one machine goes down, no issue. Something else will come in. Then security-wise, HDFS does not support POSIX standards. It's not POSIX compliant, so some of the customers have some issues around it because they're used to Linux and Unix kind of system environments. So GPFS is by default a POSIX compliant stuff. It supports it. Same comes to random read and write. Architecturally, HDFS was meant for sequential reads. where GBF is meant for random read and write, so it can handle random read and write. And there are some additional things like you have one thing for 20 years. So yeah, I think that's good enough for difference between the two. Okay, any other question? Did I miss something? Okay, so I don't see additional questions coming in here. Okay, so I think I'll
Yes, hello.
yeah,
Yes, Srinivas, most of the questions are answered now, so I think we can conclude the webinar now.
thank you. Thanks a lot for your time and patience listening me. I'm sorry I took a little extra time than I was planning to. This edit because subject is quite vast. So please, you're most welcome to IMTC or contacting me for any other things you want to learn more about this. And thanks for giving me this opportunity. You and thank you. Thank you.
Thanks, Srinivas, for your session on Big Data Analytics. It was indeed an enlightening session. I would also like to thank our participants for their support in making this webinar a huge success. The recording of this webinar will be available on techgeek.com by tomorrow. Thank you all once again.